facility, girls-friendly and secured campus, playgrounds. For more details, contact MES College Erumely, approved by Government of Kerala and affiliated to the Mahatma Gandhi University, Kottayam. MES College PO, Erumely, Kottayam. Welcome to MES College Erumely. Accessible and affordable quality education. MES College Erumely is a first grade unneeded. Welcome to MES College Erumely. Accessible and affordable quality education. MES College Erumely is a first grade unneeded arts and science college under the Muslim Educational Society and is affiliated to Mahatma Gandhi University, Kottayam, an ISO 9001-2008 certified institution. 2021-22 admission started UG and PG courses. BCom Computer Application, BCom Finance and Taxation, Marketing, Office Management and Secretarial Practice, BSc Electronics and Psychology, BCA, BBA, BA English and Literature, PG courses, MCom Finance and Taxation, Marketing and International Business, Management and Information Technology, MSc Electronics and Computer Science, MSW, MA Economics and English. Our specialities: eco-friendly campus, qualified faculties, high-tech computer lab, hostel for boys and girls, well-equipped library, transportation facility, girls-friendly and secured campus, playgrounds. For more details, contact MES College Erumely, approved by Government of Kerala and affiliated to the Mahatma Gandhi University, Kottayam. MES College PO, Erumely, Kottayam. MES College Erumely. Accessible and affordable quality education. MES College Erumely is a first grade unneeded arts and science college under the Muslim Educational Society and is affiliated to Mahatma Gandhi University, Kottayam, an ISO 9001-2008 certified institution. 2021-22 admission started UG and PG courses, BCom Computer Application, BCom Finance and Taxation, Marketing, Office Management and Secretarial Practice, BSc Electronics and Psychology, BCA.
Rekama?
Yes, sir.
Let us start or some wait.
Yeah, I think we can start.
Okay, ma'am.
Okay.
Yeah, Lilina and first.
Dunia?
Good afternoon, everyone. Welcome all to the third day of online workshop on statistical data analysis using R programming. I welcome our resource person, Dr. Bindu Krishnan Madam, Head of the Department of Data Science. And I also welcome all the participants. The feedback link will be shared today for the EAT certificate and it will be closed at 5 p.m. today. So everyone make sure that you filled up the feedback form and there is a validatory session at the end of the program. So let's begin our program, madam.
Yeah. Good afternoon. Good afternoon, dear participants. So let us continue with. I hope all of you have practiced how to import data set and how to deal with the basics in R. So let us start straight away because we don't have much time to waste. So before starting the session, those who have already practiced with this, if you face any difficulty or if you have any queries, you can ask me now. Any queries based on previous sessions, yesterday 2 days sessions? And one more thing, actually yesterday I faced one issue in exporting to Word file. Actually that my Windows firewall blocked that. So let me show you first how do we import or how do we export this to either to a Word file or PDF file. But PDF, it is possible for you to export to as a PDF file provided LaTeX is installed in your system. Otherwise, you can export it to a Word file and you can convert that Word file to a PDF file. Okay, so first I will show you that. Okay, So just I will show you how to convert this as an export file. This is how to convert this as a Word file, or how to export this as a Word file. So first anyway, let me execute all the codes. So I have executed the codes, all the codes, no error comes here. But if some error come, you will not be able to convert it to a Word file. First fix that issue, then only proceed. Okay, so I have executed this code. So I'm going to convert it as a Word file. Just simply click niche document, then MS Word, compile. Okay. So either that Word file will be saved in the same folder in which you kept your R code, or you can see that it will be here minimized. It will be here in your taskbar. Look at this, the same thing I got it. See, all these codes with its output. That means this one. Look at this. It will be directly saved as in wherever you saved your R code or R file, same R file. So it will be saved there. Otherwise, it will be in this taskbar. You can just minimize this. So I hope it is clear to you. But PDF file, you'll be able to convert it to as PDF file. See, actually, here, this is the PDF file I will show you. Okay. PDF file, I don't think you will get it because you don't have that LaTeX. PDF will, you can see that it will convert through LaTeX, LaTeX, LaTeX. So you may not get it. Those who have installed LaTeX in your system, definitely you will get it. At least you will get that LaTeX file, then open that LaTeX file, execute it, so that it will convert to PDF file. Okay. So anyway, I'm not, okay. Here actually I got it. I got it as a PDF file because that LaTeX is already installed in my system. But for you, I don't think you will get it. Okay. Okay. So let us continue with. And one more thing, yesterday actually why I was not getting it yesterday, two reasons are there. One thing is it's my system fault, that is Windows firewall blocked this. But one more reason there why I was not getting it. The reason is that actually I have executed only some codes up to this one, up to this. And I didn't execute the remaining codes. So once you have a set of codes below that, and if you forgot to execute that, you cannot convert it into a Word file or PDF file through NID document. So that is why now I just copy a set of documents to another file. Then I just execute it, then convert into a PDF file. So yesterday that was also one problem which I faced. I forgot to execute the remaining codes because remaining so many codes are there here, but I didn't execute that. Okay, that is also one of the reasons. Okay. So anyway, so let us continue with the yesterday session. So I request all of you to first we will start. And one more point I would like to mention. Actually, while converting to Word file, after doing some analysis by importing dataset or something like that. So yesterday I showed you, we studied how to import a dataset by clicking this, right? Wherever dataset is there. So if this dataset is there, let me import say grades dataset, grades. Okay. So grades dataset, I'm going to import say grades dataset. Okay, I have imported a data set named as grades. Okay, so while importing data set, after that, if you are going to do some data manipulations, finally, if you have any plan to convert it into a Word file. Okay, so after importing data set, definitely you will do some analysis with that data set. Then finally, if you have any plan to convert this as a Word file using niche document, while importing data set, you will get a code here, right? You will get a code here, that is grades equals, grades is the data file name, read.csv, then this is a location which I saved my my data set in a folder. So please copy paste, then paste wherever you are executing that, paste here, execute that code once again. So why we are making a copy paste? The reason is that whenever you made some function, you made some function by clicking, that will not accept Word, that NID document. Okay. So if you have any plan to convert it into a Word file after doing all the analysis, while importing this data set, after importing through this text base or whatever is that, after importing this, you will get a code like this. Please copy paste this code here and execute it once. Because whatever you convert to NID file, all those codes need to be there. Right? ഇവിടെ നമ്മൾ ക്ലിക്ക് ചെയ്തല്ലേ ചെയ്യുന്നത്, ക്ലിക്ക് ചെയ്യുന്നത് വേർഡ് നെറ്റ് ഡോക്യുമെന്റ് അക്സെപ്റ്റ് ചെയ്യില്ല. നെറ്റ് ഡോക്യുമെന്റ് വിൽ നോട്ട് അക്സെപ്റ്റ് ദാറ്റ്. Whatever you click. Also, while importing packages, I told you while importing packages, it is enough to check that package here or not. Suppose if I want to import this package, it is enough to click here. Okay, by clicking here, definitely that package is imported. Fine. But if you have any plan to convert it to a Word file, please type this code or copy paste this code and execute it in this menu, this editor. Okay. So please remember one thing, whatever you are doing by clicking without using code, like import data set or this one, library, that importing packages. So whatever you are doing by simple click, please type corresponding code, provided convert it into export it into as a Word file or PDF file or HTML file. That's all. Otherwise, if you don't have any plan to convert it into a Word file, there is no need of copy paste. It is enough to do this like this, click this, just import that like that. That's enough. It's important because this grades is here. It's important. Okay, so these are few points which I would like to share you. Okay, let us come back to the descriptive statistics. Next is descriptive statistics. So I request all of you to import this data set grades. I request all of you to import this data set grades. So we are going to find mean, median, etc. for this grades. Simply click this import data set, first one or second one, no issue. First one, then browse wherever your data set comes. So this grades, click this, open this, that's all. While opening this, you will get a window like this. Don't forget to click this yes. I don't know, earlier let me import once again, because I don't know whether I checked that column as yes in the previous case. Yes, then import. Okay, so I have imported data set. Go back to here. So head grades, look at the first code. Head grades means if you want to view the first few rows of these grades, look at this. This is the data set grades. You have serial, actually here 1 to 9 of 105 entries are there, 22 total columns. Total columns 22 and 105 entries. By dragging here, you can see here. See, 105 entries are there, and here by dragging here, you can see this last column up to last column. Right? It is showing 9. So and showing here, showing means whatever it will change. See, 1 to 9, that is why here 1 to 9. But if you drag like this, you can see this. So total 105 entries means 105 rows and 22 columns, right? Okay. Suppose you want to see the first few rows. If you want to see the first few rows, the code is head grades. first few rows. Look at this first few rows. That is 1 to 6. 1 to 6. 1 to 6. See, 1, 2, 1, 2, 3, 4, 5, 6. Serial number, ID, last name, first name, gender, ethnicity, year, lawyer. Then next one comes here. Section, GPA. Next columns comes below. R is having some limited space limitation. So that is why in continuation of this column, next to low up column, next column is section, GPA, extric, then review, quiz 1, quiz 2, quiz 3, etc., etc., etc. Then after this total, this column, again, person, grade, pass, fail, etc., etc. So if you want to view the first few rows, say 5 or 6 rows of the data set in the console. Similarly, if you want to view the last few rows, here actually I got it as 1 to 6, right? 1 to 6. 1 to 6 means this 1 to 6. Suppose I want to get it as last one. This last few rows. Okay. In that case, tail grades, tail, T-A-I-L, tail, last one, tail. Look at this, 100, 101, 102, last few rows. It starts from here. Serial number, 100 correspond to 100. What is the serial number? Then what is the ID? These are the rows here. Look at this, serial number, ID, last name, first name, etc., etc. Okay, then dimension, DIM is dimension. Yesterday I mentioned that while dealing with the metrics, DIM is dimension. That means how many rows are there, how many columns are there. We have 105 rows, 22 columns. Then names, what are the names? Headings, titles, these are the headings. Titles means top, these things. These are the names. Names means the titles of column title. Okay, structure means each of these contains how many? Structure, just give you a structure of this. See, sorry. Structure, look at this. In the first one, serial number actually integers 1, 2, 3, etc. Then ID also some integers. The next one, but last name is not an integer. Last name is a character. Can we check that? Look at this last name. This column is not an integer, character. So character actually it is given as CHR. Okay. Then what all characters are there, etc. So many things are there. 105 entries are there. That is why, etc. Okay. So you will get a structure of our data. STR is the code structure. Then to view the grades, yesterday I showed that how to view. Simply same thing, you will get it as a column. Right? To view this. V is capital letter. Then summary. But before moving to summary, if you want, you can check simply. Suppose, listen. Suppose I want to get this number, average of this number. Average of this number. Some numbers are there, ID. Okay, some integers are there. So how do we find the numerical value? If this is a numerical value, then only we'll be able to find the average. So what is the average of these values? ID is the column heading. Okay, so how do we find that? Mean, MEAN, mean is the R code for finding average. Bracket, first write the file name of data set. First, put a dollar symbol. So while putting dollar symbol, you will get all the column names. So I am going to find the ID. So you can select this. Otherwise, you can type ID. Okay. Can I check this? What is the average of that value? See, this is the average of that column. This is the average of this column. There is no meaning in finding the average of ID, but just I showed you this one. Or you can maybe you can find some. Let me find the average of this GPA. So let me find the average of this GPA. How do we find the average of GPA? Mean, grades, GPA. Mean, grades. Then we use the dollar symbol to select a particular column. One other way is also there. I will show you. Okay. I had done it here. I'll show you. Okay. So now in the next code is in the summary grades. Summary grades means you will get all these values. I will show you. Not only average, some other descriptive statistics also. You will get all the things. Look at this. Summary grades. Summary grades means first, that is corresponding to each of these column. Corresponding to each of these column, what is the value of minimum, first quartile, median, mean, third quartile, maximum. All these things we are getting with a single code. So if you have any plan to find all descriptive statistics, there is no need of going individually like mean, median, mode, etc. You can straight away type this summary grades. Summary bracket your file name. And if you want a particular column only, if you want to get the summary of all these things are here. Look at this. If you type this code, summary grades means summary such as minimum, first quartile, median, mean, third quartile, maximum. All these values corresponding to each of these rows. Each of these rows in the sense for this characters you will not get it. But wherever values are there, you will get the minimum value, maximum value, first quartile, third quartile, then first quartile, third quartile means Q1, Q3, then median, mode, etc. Okay, but look at this serial number, ID, what is the minimum of ID, what is the maximum of ID, what is the median, mean, first quartile, third quartile of ID column. Then last type, actually it is a character, so we will not get any of these values. First type, that is again character. Then remaining is there, below that this gender. In that also, even though that gender is, we have only 2 and 1, in that 2 and 1 also are calculated, minimum, maximum, all those things, etc., which is of course meaningless. But for getting all the things, suppose all the columns contain some numerical values, some real numbers. In 1 second, you will get it all these things. Okay. Then ethnicity for all these columns. For all these columns, you have these values, measures here. Look at this here. Finally, this grade. Grade is not a, see, the grade is not a number. That is why I am getting it as a character. Length is also not a number. So this is pass fail, not length, sorry. Pass fail. This is also not a number. That is why I am getting character. Okay. So this actually I have found the summary of all things, all measures. Or sorry, summary of all columns. But suppose I want to find the summary of that column GPA only. GPA means, where is that? GPA. This one. Suppose I want to find the summary of this column only. Then it is enough to type summary, bracket, grades. Grades is the file name, dollar symbol GPA. Let me check that. Sorry. Right. Look at this. So, in corresponding to this column GPA, what is the minimum? What is the first quartile? What is the median? What is the mean? What is the third quartile? What is the maximum? So, similarly, you are free to choose any particular column and you can find it. Do it up to this. Up to this one. Simple code. That this actually, this summary, this list contains actually some measures are not included in this. Say, for example, skewness is not there, kurtosis is not there, or standard deviation is not there. So if we want to find more measures such as standard deviation or mean deviation, skewness, kurtosis, etc., in that case, you can run this code. Please execute this code. Describe. Summary is 1R code for getting these measures. But can you all please type describe and check whether what happens. Describe bracket grades. What will happen? You will get an error. I will show you error in why. The thing is that for executing the describe, we require a package. psych package. First day, actually, I requested all of you to install a package known as psych. So if you have installed that package, PSYCH, then it is enough to check that. Just make a click. That means you have imported. I'm not giving you time for installing now because that is the first day exercise. It is enough to make a tick. We have imported, which means that look at the console. That code will come here. Or without searching here, you can type this code also. Why I include this code here? The reason is that if you have any plan to convert it to a Word file, after doing all these things, you need to type it like this. Okay, Word file ആയിട്ട് convert ചെയ്യാൻ plan ഉണ്ടെങ്കിൽ എന്ത് code നിങ്ങൾ click ചെയ്ത് ചെയ്യുന്നോ, whatever code, if you have any plan to convert it to Word file, then whatever things which you are doing here by simple click, please do that code, type that code and execute it. Okay, but here we don't have any plan, so no need of typing here. No need of typing here if you don't have any plan to convert Word file. Okay, but anyway, now check this describe. See, I'm getting it. Now check this describe. I'm getting it. All the codes, all the things. See what all things are there. Number of values there, mean there, standard deviation, median, trimmed value. MAD means mean absolute deviation. Again, measures are there. Minimum, maximum, range, skewness, kurtosis, standard error, everything there. Suppose I focus on, say, any one column. It would be more clear to you then. Describe, grades, see, GPA. Let me focus on any one column. So it would be more clear to you. Yeah, look at this. For if you focus on any one column, GPA, any column of your own choice, other than characters. Okay, so that you will get all these measures. Please do up to this. Not only up to this, see below that actually I have included how to find these things separately. How to find mean, median, variance, standard deviation. IQR means interquartile range. Then quantiles, 0.9 actually 90th percentiles. I hope you all familiar with percentiles. 90th percentile or 70th percentile like that. So you need to mention here. So those who want, you can get practice with this also. Anyway, it is mandatory to do this one, summary and describe. Okay, do it. And if you have any doubt, please ask me. So that's all with the descriptive statistics. If any doubt, please ask me.
Hello, ma'am.
Yes, please tell me.
Okay, ma'am. Suppose that it be take the continuous data in group form. Means
Continuous
suppose that
data
in a
in-
class interval in
wait,
group
wait,
form means maybe in a class interval form means 5 to 10, 10 to 15, 15
Yeah.
to 20 like this.
Yeah.
So how to calculate the mean and mode for this data, ma'am?
The same procedure.
Okay, same procedure.
Same procedure. Same procedure.
Can you demonstrate, ma'am, if you have time?
Yeah, I don't have any data at present for with classes. And one more thing, the same data itself, if you want, we can convert in. You can convert into classes. Like you are telling about the frequency distribution, right?
Yes, ma'am. Huh.
Yeah, same data itself you can convert into frequency distribution, and you can do it.
Okay.
So only thing is that the code which we use for finding mean or average is simply MEAN. That is our code.
Okay.
And one more thing I will show you. See, we can avoid this dollar symbol. We can avoid this dollar symbol once you import data set. See, here actually we import data set, right? Import data set. If you run this code, if you type this code, attach grades. Suppose after importing data set, I am executing one code, attach grades. What is the advantage of this attach grades? In this case, once you attach that file name, it is enough. For example, say for finding mean. For finding mean, mean it is enough to type the corresponding column name only, that is GPA only. No need of typing that file name again. Mean of GPA is enough. No need of taking, look at this mean of GPA. No need of taking grades, dollar symbol GPA. Okay, so that is another advantage. Attached data set. Yesterday, one participant actually asked how to, sorry, is it possible to insert one? Did you check that? I forgot her name. One participant, I think Annie. One participant asked me, is it possible to insert? Did you check that? No, that participant is not there. Okay. Over?
Madam, please show the code after attaching the file. I didn't get that.
Sir, pardon, sir?
After attaching, I got an
here.
error.
ഞാനത് ഇവിടെ ഒന്നുകൂടെ ടൈപ്പ് ചെയ്യാം സാർ, ദാറ്റ് ഈസ് ബെറ്റർ.
Okay.
Attach grades. So attach grades. I have attached grades. Now it is enough to, it is better. After this, ഇത് കഴിഞ്ഞ് ചെയ്യാം, അതായിരിക്കും. Okay. So after this, it is enough to say for finding mean, it is enough to type the code, type that column name only. So once we attach, no need of typing that file name. Attach file name venda. Here actually we have typed the file name, then dollar symbol, corresponding column. It's not required.
Okay. No.
Okay. I think you asked me this thing, same, sir?
Yes, madam.
Okay.
Clear.
Okay. So, okay. I hope it's over. Is it over? Okay. Now next is visualization. How do we plot histogram, bar chart, then pie chart, box plot, etc. Okay. So first we start with histogram. I'm going to do it with same data set. Histogram. It's symbol code. HIST is the code. We have already imported data set, so we can continue with that. I'm going to continue with the same data set. Great. HIST histogram code. R code for histogram is H. R code for histogram is HIST bracket, then write that grades, or if you already attached data set, it is enough to type GPA only. Hist bracket grades, just choose any one column from this. It is not necessary that you always choose this one. You are free to choose any column, like giving values of like this, this column, or whatever. Don't show the characters. Don't choose the characters. Okay. So hist, then bracket, write that column title if you attached already. Otherwise, file name, dollar symbol, that column title, comma. If you want to give a particular color, that is optional. If you want to give a particular color, COL equals quotes, give that color. So let me show you. See, this column is, this is optional actually. Otherwise also you will get simply hist is the code, hist in bracket, then also you will get it as by default. But if you want to insert some color, comma, COL equals, don't put inverted comma, BLUE or red. Let me give some other color, red. Okay, do it. HIST, H-I-S-T, that is the only code which you are using. Over? Okay. Now next line is actually optional one. If we look at this one, look at this data set. Actually, histogram of grades underscore GPA, that is the default title which you are getting. If you want to give a title of your own choice for this particular diagram, if we want to give a title of our own choice for this particular diagram, you can type it as all the options will come continuation of this color. See, his bracket, the first one will be that file name or that particular column name. No change in that. Second term onwards, you are free to give different options such as color already I have assigned. Look at this next one, XLAB. XLAB means a label of X. See, here actually by default you will get a label. Suppose I want to give a label, say XLAB equals G. I want to give a label G. Then I want to give a Y label. Instead of this frequency, suppose I want only FREQ only. Our choice. Then main equals, main means this heading. This heading, histogram of GPA underscore GPA. Suppose I want to get histogram of GPA only. Then column equals, sorry, color, COL. COL is color. Actually, color equals some color of your own choice. All the basic colors are available. Then again, XLIM means limit of X. Look at the limit of X. Here actually I am getting 1 to up to 4 only. Suppose I want to get the limit here as, not 1, 0 here, 0, 1 like that, 0 to 5. Suppose I want the limit as 0 to 5, that is maximum as 5. You can give that. By default, of course, but you can say all these things. Then YLIM means limit of Y in the range between 0 to 30. Here actually we can see only 0 to 20, but 0 to 30 if you want, you can. I will show you all these things. See, 0 to this up to 30, then 0 to here, 5. Then G is the label which I have given. FREQ is the Y label I have given. Okay. So these are all optional. If you want to specify more things, I think I can copy this in the chat so that it will be easy for you. Okay. I sent in chat box, posted in chat box. Those who want, I never ask you to copy paste, but if you have any doubt, you can have a look at the chat. These are all options. The thing is that once you get familiar with any one diagram, say histogram, all these things remain same for other diagram also, like box plot, bar chart, then pie chart, etc. All these codes remain same. Only difference is in this first part, hist. If you are plotting a pie chart, PIE, it comes as PIE. Do it. I think histogram, all of you have an idea about histogram because you all studied this in your school classes. If you have a set of values, see here actually simply I have a set of values only. This R is automatically converting it to classes. For doing histogram, actually we have to divide it into classes, frequency distribution. Then after dividing it into classes, how many values comes in each class. So based on that, actually we plot this. So one participant asked me, I think Dr. Ram Kumar, sir, here actually it's directly converting to frequency distribution. No need of converting individuals, doing individual steps.
Okay, thank you, ma'am.
Okay, yeah. Because now usually while collecting data set, data will be of only this form, not in classification format or tabulation format. You have entered some data, but in that case, in R actually no need of doing that specific distributions. Directly you can do it. Okay. So those who want to know more about histogram, see, please put before that one more thing. Here actually we all of you got this histogram?
Yes.
Okay, okay. Now, once you get a plot like this, how do we save this? Before moving to next code, how do we save this? It is very easy. We have different options. Click this export. Okay, you can save it as a PDF file. Save it as a PDF file. Okay, so click by here actually directory you can choose wherever you want to save, desktop or wherever you want to save, you can choose and open. And here also you can give a name of your own choice. Name of your own choice, file name. Then save it. That is one option. This option is save as PDF file, or you can save as image. Save as image. Click this. Click this. Here you can choose the directory, then file name you can give. Then here also different options are there. PNG, you can save it as a PNG file or JPG file. So many options are there. Okay. Suppose I am saving it as a PNG file and directory I am going to choose as my desktop. Open. And here actually I am giving a name, say hist. Okay. Then save. Okay. Let me check whether it is there in my desktop. See. Okay. So I have saved it as a JPG file, but you are free to choose any of the options from here. Okay. So first option is save as image. You have different options here. These much options are there. But before that, check whether, suppose you want to save it as an EPS file, check whether in your system it is installed or not, EPS. Otherwise it won't work. Okay. Then third option is copy to clipboard. Suppose you want to copy and paste in a Word file. See, copy plot. Let me open one Word file. What is that? Say, let me open one Word file. See, right button, paste. Okay, so that's also possible. So that is how we export or save that file. Okay, just come back to here. To get a help in R, suppose you want to get more about this hist. Put a question mark, hist. Just run this. You can see in the right side here. See what happens in the right side. See, you will get all the things about his, all the things related to R code in histogram. Okay, so you can have a look at it if you want. Everything, whatever things which you want, you can just put a question mark and type that. Or one more option, HELP, help bracket hist. In that case also you will get help bracket hist. Okay. Same thing. Help bracket, say box plot. Suppose I want, this is actually already I got Instagram. Help bracket box plot. See, you will get all the details regarding the box plot. Okay. So that is it. Okay. Anyway, so can we move it to more data visualization? One thing remember, for more data visualizations, only difference is that in this code, the first one will change. Instead of hist for histogram. The R code for histogram is hist. Similar to that, R code for box plot is different, bar chart is different, then pie chart is different. Only change in that first one, this one. All the other things remain same. I'll show you. Next is box plot. For simple plot, how do we plot? Simply, simple plot. Plot grades of GPA. Simple plot. Simply I plotted that points. I took that points in the y-axis, first point, second point, third point, like that. Simple plot. Plot, bracket, that name. Then, if we want to get a box plot, grades, then all the options also I have given, which we have given here, X label, Y label, then main equals, then see, one more thing. Here actually, no one asked me one doubt, why I took this onwards in the next slide. No issue. This code, you can write it as the continuation of this. No issue in that. It will go like this. That's why I took it here. No, it's possible. It's possible to write the continuation of code here also. Or you can type this here, continuation of this. No issue in that. If it is a lengthy code, it is better to type in the next slide. Okay. Okay. So next is box plot. Box plot, the R code for box plot is simply BOXPLOT, that name. Box plot. Okay. Then grades, X label, Y label, then main equals. Let me get a box plot. Either you will get horizontally or vertically box plot, because so many plots are there, maybe you will get vertical plots. I don't know whether you are aware of this block. Let me give an introduction of how to interpret this. Look at this. This is the shape of box plot. Either you will get in vertical shape or horizontal shape. Okay, whatever be that. So if it will be of this shape, this central line corresponding to this one value will be here, no? That will be the median. Central line will be the median. Then in this box, central line. The lower end of the box is first quartile. Lower end of the box here, corresponding to here, whatever be the value here, that will be the first quartile. Similarly, upper end of the box is third quartile. Lower quartile, median, third quartile. So Q1, Q2, Q3, like that. Q2 is the median. Then this range, this width, okay, this width, that we call it as interquartile range. Then this last one, this will be the minimum value. This here, this line. This will be the minimum value and this will be the maximum value. So that is the interpretation of box plot. And this is one of the important technique for realizing or for detecting outliers. Outliers in the sense, suppose you have a set of values, say 1 to 100. Suppose you have a set of values 1 to 100. In this 1 to 100, only one value will be, say, 1 lakh or 50,000, like that. All other values lies between 1 and 100. So that 50,000 is an outlier. So in case, while plotting a box plot, this outlier will lie either above this line or below this line. If you make a plot of this box plot, outlier will lie either below this minimum value line or above this maximum value line. So that is the interpretation. So this is the easiest way of detecting outliers. Okay. If you want, I can put this in chat. Box plot. And next is actually, here actually I have plotted only for GPA. Suppose you want two things, one against other, that is here, this is GPA actually, this is ethnicity, then ethnicity and GPA. GPA versus ethnicity. Taking GPA in the x-axis and ethnicity, sorry, not GPA, x-axis and y-axis. So in this GPA itself, how that ethnicity divides, I will show you that it will be, then it will be more clear to you. Simply GPA versus ethnicity. That is, if you consider two factors, two features. Okay. Then look at this code. Box plot is the code for box plot. Box plot. Then GPA versus ethnicity means I have considered two features. Then these two features comes from grades data. But if you attach the data, if you attach the data set grades, you can avoid this code. Data equals grades, you can avoid. Once you attach that. Otherwise, you need to type this. Then all other things, options which is same as the above. X label, Y label, main equals, then color equals. Look at this. What? See, I hope it is clear to all of you. See, for ethnicity, each of those values, what about the value of GPA? That is multiple combinations. Multiple combinations. I can copy paste the code. Pasted in the chat. That's not actually a good practice, but these are all only optionals. That is why. Check it whether you all are getting it. In the next code also only small difference I have given. Can you all listen here? Here actually color equals blue. Suppose I want to give a different colors for these different charts. So that is color equals heat dot colors. So many varieties are there like this. Heat dot colors, topo dot colors. So what will happen if I give heat dot colors? 1, 2, 3, 4, 5. 5 colors are there. That is why I have given color equals heat dot, but there no need of giving codes because it is a code actually, heat dot colors. Okay. See, different colors. Now, another option is topo dot colors. Topo dot colors, different colors you will get. Similar to this, some other options are also there. You can have a Google searches how to give different colors in box plot. Okay. This code also, if you want, I can do. Heat dot colors code I have posted in the chat, but simply change, for getting this, simply change TOPO. This is only difference. TOPO. Do it. This data visualization actually plays a major role nowadays in data analysis. Not only data analysis, once you focus on data analytics, those who are working in data analytics, all those things, no? These are the simple and humble way of expressing our data set, presentations in presentation style. And even some softwares itself are available for only focusing on data visualization, like a Tableau. Some of you may have heard about this Tableau, all those things. There actually it is purely for data visualization. So many different ways are there for expressing these type of data visualizations. Because those always the customers or clients, they may not be aware of advanced statistical techniques, but all are aware of these type of visual presentations. So nowadays it is very important, not only in the business perspective or industrial perspective, in research also this plays a major role. Subjects other than mathematics and statistics, I can say. So statistics and mathematics, you can see, usually focus on theoretical concept, methodologies. They are contributing more methodologies than analysis. The difference is that usually statistics and mathematics people will develop some theory, then only they will go search for data. But others are doing what others are doing. They will start with a data set, then building model from that. Right? That is the just reverse of that. We are not doing like that. Our final task is to find a data set, but we can't take any data. we will first develop a theory. We have to find a data set which is suitable to this, and we have to prove that this methods or these techniques provide better results than the existing one. Okay, anyway, that is the part of research. So I hope the box plot is over. Now come to scatter plot. Okay, for scatter, simple plot, already I showed you simple plot, but suppose I am choosing, say, GPA and final. GPA is one column. GPA is, where is GPA? This is GPA, and one more column I have chosen here, this final column, this column. Any column of your own choice, you can choose any column from this. So suppose I choose GPA, one column, final, other column. So how do we get a simple plot in the x and y axis? By taking GPA and final. Plot, simply plot. Either write GPA comma final, or if you don't attach that data set, you write that file name $GPA, comma, just put by comma, separate by commas. Then if you want to give a title, give scatter plot, then color. Sorry. See, here GPA along x-axis and final along y-axis. If you want to give some see, comma, x label, XLAB equals, say, GPA. Suppose I put XLAB equals GPA, so that this will change. See, look at this. This will change. Those are all optional. Okay. Or if I want to, I want to draw a line for this. AB line, linear model, regression model, linear model. If I want to draw a line, that is making a line, fitting a line. AB line, look at the code. AB line equals LM. LM means linear model. Bracket, grades, final versus, here don't put this prompt symbol. CS people say this is prompt symbol. Others say mathematics people that approximation symbol. You can see the left side of your keyboard. Prompt symbol. So AB line bracket LM is the code. Then again in another bracket write that file name with corresponding column versus, of course, we require AX plus BY equals C. So XY, 2 columns are required minimum, right? So that is why final, and I have chosen here as final and GPA. You are free to choose any other columns. Color equals red. Okay. One example is that. I posted in the chat those 2 codes. Why I am posting in the chat? These are also, once you get familiar with the data set, these are all simple things. Some either how to give labels, how to give limits, all those things, only basic things. That is why. Then another type of chart is dot chart. Dot chart. This is a dot chart. Okay. So these are the cases only in the above previous cases. I have chosen only 2 features, 2 variables. But suppose you want to choose 3, 2 or more than 2. Final, GPA, QS. Okay. So in that case, we can plot scatter plot. We will call it as scatter plot matrix. Look at this. Scatter plot matrix means, look at this picture. I will tell you what is this. See, suppose take this figure, this figure. This figure means What does this represent? This figure, this is the plot between final and GPA. Plot between, that is multiple pictures you are getting at a time. Plot between final and GPA. Suppose take this one. What about this one? This is a plot between final and GPA. Final and GPA. And what about this? This one? This one? This is the plot between GPA and quiz. Quiz. So here actually I have chosen only 3. Final, GPA, quiz. But look at the next code. The code is simple, pairs, P-A-I-R-S, pairs, bracket, write the file name, that is grades, then square bracket, C function. Yesterday we studied C function. Inside this C, you can give the, I can give you in the chat. Okay, then one extra term is there, PCH. What is this PCH? PCH means, see, I have given some markings here, right? Not myself, R has given some markings. We can change that. Suppose I change this PCH to, say, instead of 5, I am changing it to, say, 10. Okay, I am going to execute it. Check whether any change in the shape of this point marking. Is it changed? Okay, so by giving different values here, there's suppose 15 I am giving. Again, change. Okay, so by giving different values, you will get a change in shape of that markings. Actually, I show you a list is there. See. Okay, these are the PCH represent. If we take PCH as 0, it is a square marking. If marking that point marking, not dot, it will be a square. Then PCH is 1 means circle, PCH is 2 means triangle dot point up. Actually, we took this PCH equals 5, which is a diamond shape marking. PCH is 10 circle plus like that. Oh, a list is there. You will get it in Google. If you want, I can post in Google Classroom also. Okay. Okay. Then. Okay, so here actually I took, I hope all of you have done this. Here actually I took only 3 features, 3 variables, final, GPA and quiz. Suppose I want to take more, final, GPA, quiz 1, quiz 2, quiz 3, etc. More features, more variables. See, all the things you will get it. So many plots. Okay, that is scatter plot matrix, multiple plots at a time. You can paste in the chat as well. Okay, I posted in chat also. Do it. I'll wait here. Over. Are you all getting it? No responses from the participants. Complicated ആയി തുടങ്ങിയോ? Are you feeling much complicated? Don't worry, evening after today evening itself, I will share this in the Google Classroom, both R codes and the PPT which I took in the first session. So this code also I'll post in the Google Classroom. So in between, if you got stuck up with some codes, you can have a look at this. Okay. So next is we are moving to pie chart and bar chart. One difference is there. Pie chart and bar chart. Pie chart and bar chart, we require. So this is also based on that participant, Dr. Ramkumar, your doubt. See, for making pie chart and bar chart, we need to prepare a table. That is table. Suppose I am choosing this, say, gender. See, in this column, we have only two numbers, 1 and 2. Right? In this column, we have only two numbers, 1 and 2. Say, 1 represents male, 2 represents female. Or 1 represents female, 2 represents male. So first we need to find how many ones are there, how many twos are there. Before moving to pie chart or bar chart, we have to find how many ones are there, how many twos are there. Categories. Right? So that is why here actually I am preparing a table. Table is the R code. TAB is the name which I have given. TAB. In place of TAB, you are free to give any name of your own choice. Okay. But table is the R code. Bracket, that file name and which column you want to choose. That's all. Okay. So if I want to see the table, look at this. Look at this table. How many ones are there? 64 ones are there and 41 twos are there in this column. In this column. This column total 64 times 1 on and total 41 times 2. That is the meaning. Okay. Now you can draw. And similarly, I have found a table for this column also. This column also. Ethnicity also. Ethnicity also. Table grades ethnicity. Okay, table TAB1 is the name which I have given. Then R code is table. C-bind. What is the meaning of C-bind? Nothing. C-bind means if you want to get this as a column, this as a row we are getting, right? If you want to get this as a column, if you are, you can type C-bind. See, table tab 1, that is this ethnicity table. We have 1 repeated 5 times, 2 repeats 20 times, 3 repeats 24 times. I can show you ethnicity. See here. Look at this ethnicity. 1, 2, 4, then 3, 5. 1, 2, 3, 4, 5. So here in this column actually 1 repeats 5 times, 2 repeats 20 times, 3 repeats 24 times, 4 repeats 45 times and 5 repeats 11 times in this column. So why I prepared this reason is that before making pie chart or bar chart, we need to find the count of that. Now it is very easy for getting this gender, pie chart of gender, PIE. That's all. PIE bracket that table name. PIE bracket that table name. Okay. Then bar chart, BARPLOT, bar plot itself is the code. Bar plot bracket that table name. Then additional options such as giving color, giving name, X label, Y label, all those things you can see. Here actually in this TAB1, how many options are there here? TAB, 5 options are there. Listen. For TAB, it is enough to give 2 colors because only you have 2 options, 1 and 2. But if you are choosing TAB1, TAB1 corresponds to ethnicity, where ethnicity you have 5 options. So you need to give 5 colors. 5 colors in C function, using C function. Look at this pi. Simply pi tab means that that's all. PIE bracket TAB1. Pie chart of ethnicity, you will get it like this. That's all. By default, you will get a color like this. But if I want to assign some colors here, say red, blue, magenta, green, like that, pi bracket tab 1, comma, COL equals 5 colors are required. So more than 1 required means we use C function. C bracket each of those. See. And you are free to give, say, XLAB, X label, Y label, all the things which you are given in the histogram, you can give here also. By evening, you can check that, all the options, X label, Y label, then main title, all those things. No range is required here. Circle, right? Here, if you want, you can give some legend here. Legend, legend equals. You can give that also, legend. Okay, same thing, bar plot also, different colors, bar plot with different colors. Give a pie chart. Next one is bar also. Okay. The thing is that actually while programming, one drawback is there. We need to be dedicated to that. We need to find time to do all these things. Then only we will be more expert in that. We will become expert in this. No issue in that. I can share this file. So those who find any difficulty in between, you can get practice with this file. Simply don't run that file directly. Always while doing programming, don't copy paste also. You can see, you can have a look at the program which I am sharing you. Look at the program. You please open a new file of your own, new R script of your own. Type it. Then only you will become more practice with that. So please practice it only by typing. Start from scratch. Over. Next code is actually nothing. If you give an additional code like this, HORIZ equals true means you will get the bar. Let me show that in horizontal shape. See, in this shape. That is one additional code I have given, this one. HORIZ equals true. That you can get practice with later. Then I told you, you are free to give different names such as already I have given a color, but instead of that, if you want, you can give names. Main equals, that means heading. Then also the name for this plots, name for, instead of 1, 3, 5, this I'll show you. Look at this. Look at this. I have given some names: Asian, native, black, white, etc. So what will be the code here? This is the names.arg. Names.arg equals C. Whatever name you can assign, you have whatever name you have, you can assign that. Okay. So that just practice with that. I will post in Google Classroom. These are only options, different options. Then some more options are there. Stacked bar chart. Just I will show you, but you get practice. These are different variations of bar chart. We already studied how to plot a bar chart, but just I am showing you some variations are there because that much importance is there nowadays for data visualization. Okay, so stacked bar chart. Look at this. How do we plot stacked? But first anyway, prepare a table. Stacked bar chart. See, stacked one. Here one legend there. Earlier I told you, you are free to give legend. See, this is the R code for giving legend. Legend. That is this male, female. Like this. Since the space is less, that is why it comes, that is overlap this. Otherwise, you will get here. Okay, otherwise you will get here. Okay, and even I zoom this part. If I reduce that, definitely I'll get here. Okay, this male, female. Then grouped bar chart. Next is grouped bar chart. How do we group bar chart? So different options are there. So I request all of you to get practice with this different. Then violin plot. For doing violin plot, actually we need to import a package. You may not have installed that package. So first install that package, then import it. Violin plot. Shape of a violin. See, violin plot. These are different types of plots. Then back plot. For all these things, it is taking time because some packages are required. That is why. See, for back plot also, couldn't find back plot. Anyway, first I forgot to run this. So for back plot also, we need to execute this code, or we need to import a package known as APL pack. APL pack, now backplot. See, this is the backplot. Okay, so these portions, of course, I have gone fast. Only thing is that these are different variations of box plot. And finally, of course, violin plot and backplot are different types of plots, definitely. But usually we use only histogram, box plot, bar chart, and pie chart. Right. So this part, if you want, you can have a practice with that. I will share you the code. Okay. Now we move to correlation and regression. But before moving to correlation and regression, we are going to work with it. Are you all with me? Are you all with me?
Yes, yes.
Okay. So correlation and regression. Correlation and regression is very easy. Actually, in between, we have already done something regarding correlation and regression, such as scatter plot metrics. You remember scatter plot metrics? That is a part of actually correlation or regression analysis. Scatter plot metrics, in that, where is that? Then one AB line we plot, that all those things are part of correlation and regression. Right. So anyway, we will do that. But before moving to the next one, I request all of you to remove that data set grades. To remove the data sets, please type RM bracket grades, because we are going to work with a new data set. So once you plan to work with a new data set, it is better to remove it from memory. So RM grades, look at this. If you want to remove all these things, just click here. Remove all objects. Everything. Please clear everything from your environment. Just make a click here. Different ways are there, RM or click here. Okay. Now I request all of you to import the dataset SLR. SLR dataset. SLR dataset is there. SLR, this one. Another dataset. Only 2 columns, advertisement and sales. This is the SLR dataset. Close this grades. Have you all imported?
Yes, yes, madam.
Okay. So correlation and regression means actually simple way of finding relation between variables. Right? The most simple way is simply plot those variables. Plot SLR. I showed you how many columns are there in SLR? Advertisement, sales. So if you want to make a plot with this advertisement and sales, plot bracket SLR _ dollar. Advertisement means here actually it is given as ADVT and SALES. Please give like this also. If capital letter is there, please give it as capital letter. If small letter is there here, please give it as small letter itself, because R is case sensitive. So whatever be there in the data set, please give either small letter or capital letter. So I am going to get a plot between these two variables. Either take this as x-axis, this as y-axis, or this in y-axis, or this in x-axis. Simple plot in this SLR advertisement, comma SLR sales. Simple plot of this. See, advertisement along x-axis. Whatever you take first one, that will come on the x-axis. Simple plot. I already showed you somewhere how to make a plot. How to make a plot already we have done. PLOT is the code. Write in bracket. Or if you already attach that SLR, it is enough to write plot bracket ADVT, comma SALES. That's all. Once you attach the data set. Color is also optional. It is your choice. Then next is COR. Next one. COR is the correlation. How to find the simple correlation? Correlation between advertisement and sales. To study correlation. Correlation coefficient. Pearson's correlation coefficient. That is the thing which we are in 1 second. 0.94. Hence there is high degree of correlation. Correlation, how do we interpret? Correlation coefficient lies between minus. That's statistics part. We are focused anyway. Let me interpret that. correlation coefficient always lies between -1 and +1. If it lies between 0 and 1, there is positive correlation. If it lies between -1 and 0, negative correlation. Okay, so 0 and 1, between 0 and 1, we get positive. And near to 1 means high degree of good positive relation, high degree of correlation. Here actually we can conclude that 0.94 or 0.95 approximately, high degree of correlation between these two variables, advertisement and sales. Okay, so correlation part is over. If you want, I can give a heading, correlation coefficient. Correlation coefficient. Similarly, correlation is over. That's all. Correlation എന്ന് പറഞ്ഞാൽ അത്രേ ഉള്ളൂ ആറിൽ ചെയ്യാനായിട്ട്. Then next one, regression. How do we fit a regression model? Look at this regression. LM, linear model. R code, MOD is the name which I have assigned. Hello, MOD is the name which I have given. You are free to give any name of your own choice. LM is the R code, linear model. I am going to build a linear model. Bracket, linear model between what all? These two things. Advertisement and sales. So LM bracket sales versus advertisement or advertisement versus sales, whatever be that. It is your choice. Okay, so how do we build a model? Okay, look at this. How do we interpret this? This is the regression part is also over. That's all with the regression. In regression, I don't know how many of you are familiar with the regression model, correlation and regression. Regression is nothing. See, we have only two variables. Let us take this as x, this as y, this as x, this as. You can find a relation in the form y equals ax plus b, y equals mx plus c, or y equals ax plus b, or x equals definitely ay plus b. That's also possible. Okay, then how do we get y equals ax plus b? So here actually sales equals a into advertisement plus b. Sales equals some constant into ax plus b. X is the advertisement, y is the sales, or you can take vice versa. That is, x is the sales, y is the advertisement. So how do we interpret this? Look at this, look at this, look at this. Y equals ax plus b. Our aim is to find values of a and b. Look at this. This intercept is b. Ax plus b. B is minus 852.08. Then A is this one. Here I took X as advertisement. X as advertisement. Whatever you took as X, you will get here. Okay. So if you take X as advertisement, only thing is that here whatever you give us, see, this one will be Y. Y versus X. That is the default form in R. Okay. So the relation is Y equals AX plus B. Here it will be, how do we write that equation? Linear regression. Y equal, if Y is the sales, X is the advertisement, then the relation between X and Y is of the form Y equals 19 point, അല്ലെങ്കിൽ sales equals 19.07 into advertisement minus 852.08. That is a regression. Okay, for getting more summary. Summary means actually we have obtained one model here. See, we want to check whether this is good or not. Okay, for that thing actually we can check it. See, in the summary you will get minimum, all those things you will get. Other than that, see, you will get a probability value here. Look at this probability value here. See, SLR advertisement or this one. Sorry, it is enough to concentrate on this value, this one. P-value. That P-value gives whether our model is significant or not. Whether our model is significant or not. If this conclusion is like this, those who are familiar with the testing of hypothesis, all those things, they know this. Just I am conveying this only for those who are not aware of this. What is the requirement of this thing is that we have already found out a value. We have to check whether it is significant or not. If this p-value is less than 0.05, if this p-value is less than 0.05, then it's significant. right? If this p-value is, actually we say like this, if p-value is less than 0.05, then we reject the hypothesis like that. Reject the hypothesis means actually we are setting the hypothesis that it is not significant. So if this p-value is less than 0.05, we reject that hypothesis so that it is significant. Reject the hypothesis that it is not significant. Not significant, reject ചെയ്യുവാണെങ്കിൽ actual thing is that is significant. Okay, so that is the case if you want to check whether the model obtained using this analysis is significant or not. And also for predicting. Regression actually main purpose is predicting. To predict that. Predict that means, see, you are given a set of x value, y values. And using this data, I have fitted a model. Say y equals ax plus b, a, b and b are obtained using this. So in that model, say y equals 19 point something, x minus 852, one model I showed you, right? In that obtained model, if you substitute this set of values of advertisement, you will get a set of predicted values of sales. That predicted values are given here. That is first one. In place of this is the actual value of sales, right? Predicted value of sales is 902.3965. Then actual value of sales, in the second column, actual value of sales 900. Predicted value is 940. 940.53. Here actual value 1020. Then here actual value is 990, like that. Okay. So do it, please. MOD is a name which I have assigned. You are free to give any name of your own choice. So in the next step, actually, I'll explain the next step also, so that I'll give you time for doing that. Next step, actually, I just plotted this linear model. How do we plot this linear model? That I showed you earlier. First, plot those values, advertisement and sales. Then how do we draw a linear model in that? So look at this, plot, bracket. First plot those two things, advertisement and sales, comma, AB line, bracket LM. I showed you earlier. How do we plot a linear model? Line, AB line, bracket LM. If you want, I can paste this also. Do it. Now I'll give you time for doing this regression. Do it up to this correlation coefficient and regression. So that correlation and regression part is over. That's all. Only thing remaining is testing of hypothesis. So those who are important SLR, please don't be lazy. Do it. Only this part for correlation regression. Correlation regression, they ഇവിടെ മുതൽ ഇത്രയും പാർട്ടേ ഉള്ളൂ. Only this part. Don't be lazy with that. Please do it. Because the regression is actually one of the important thing in analysis. Once it is over, tell me please. I'm giving you 5 minutes time for doing it. Once it's over, please either put in the chat or tell me. I can move to testing of hypothesis.
Done, madam.
Okay, thank you, thank you. Yeah. So next, last topic. Done, Pradeep. Okay, thank you, Pradeep. Okay. So last topic is testing of hypothesis. So how do we perform doing testing of hypothesis in R? So before that, I request all of you to remove these grades. We are working with SLR data set, right? So please remove this RM bracket SLR. Please remove that SLR data set. See, please remove that. Either you can give this code or please here environment, clear the environment. It is better to run that code RM equals RM bracket SLR because we are going to import new data set. Then I request all of you to please import CS2M data set CS2M. One data set is there. CS2M. Text space. CS2M is also a CSV file. Heading, check whether heading is selected or not. This is the CS2M file. So I have 1, 2, 3, 4, 5, 6 columns. BP, cholesterol, age, pregnant, the anxiety level, drug. CS2M file. Please import that CS2M file. So here it is shown 30 observations are there of 6 variables. 6 variables are there. Here actually 30 observations. 30. Okay. So the first test which you are going to perform is t-test. I hope all of you are familiar with the t-test. We usually apply this t-test in 2 cases. If you want to check whether the average value of a particular data, average value corresponding to the population. You are given a particular data set with 30 values. Of course, this data set comes from some huge population, some population. So to check whether the average of those population is 40. Say some number. Here I took it as 40. Some 40. I'm going to check whether the average of corresponding population is 40 or not. Which is very simple. Testing of hypothesis is very simple. The code is t.test. That is all. T.test. That is the code, R code. Bracket, write the data name. Then what all here, look at this. Look at this. Here we have different columns. We have different columns. So suppose I want to check the average of this age. Average of this age. Not average of this age, it is easy to calculate. But this age comes from a huge population. Right? These values, all these values comes from a huge population. So corresponding to this age also, there is a population whose age consists of a set of huge values. So we have to check whether the average of this age in that population is 40 or not. So for that thing, the code is t.test CS2M $age. $age means we are choosing that column age from the file, from the data set CS2M, comma, mu equals mu, that is the usual notation we are using. That is why mu I took. Mu equals some value you can give here. Some value say nearer to this column. Nearer to this in the sense, see, all in this column actually we have 20, 40, 25 like that. Don't take that mu equals say 1 lakh or something like that. Because while checking, no, we have to be something near to that, near to this, right? So t.test is the R code. Then write in bracket file name. Then choose that corresponding column. Then mu equals whatever the value which you are going to take it as average. You are going to check whether that is. So look at this. Simply run. That's over. How do we conclude? Same concept. P-value is there. Look at this P-value. You need to look at only the P. Actually, here test statistic, all those things are there. Degrees of freedom, everything is there. But you have to look at this P-value. In t-test, actually, we assume the hypothesis that average is 40. If this P-value is less than 0.05, we reject the hypothesis. That is the concept. That is the concept behind theory. If the p-value, if this p-value is less than 0.05, we reject the null hypothesis. But here p-value is actually greater than 0.05. Greater than means we do not reject. That means we accept this hypothesis that average is 40. We have reached the conclusion that the average of population is 40. Once again, that p-value conclusion is, please look at this p-value. If it is less than 0.05, less than small value. If p-value is small, actually we reject, right? If p-value is greater than means, of course, here it is greater than 0.05. So greater than means we accept. Okay. So here actually we conclude that the average of population for this particular population for the age column age for this particular data set is 40. That is the first test. I hope all of you have done this. The code is very simple. That is why I didn't post in the chat. Anyway. T-dot test, that's all. Then, and next t-test. Another use of t-test is if we have two populations or two sets of data. You have to, suppose here I am choosing cholesterol and BP or anxiety level and BP. So this is again, actually I have done the same thing. See, cholesterol and BP. Suppose I am considering, see, this cholesterol and BP, first two columns. So these two are the sample sets, sample 1, sample 2. Sample 1 is suppose BP, sample 2 is cholesterol. But these two sets comes from a huge population, right? One other big set of BP, one other big set of cholesterol. I want to check whether those two populations have same average. The averages of those two populations means average of population values of BP and cholesterol are same or not. We can apply t-test. Look at this. Say, this is the code. T-dot test, same code, but in bracket, you have to give both data sets. That's all. Both columns separated by commas. Here we don't require any mu value because we are going to check the equality of that. And here, hypothesis actually, what is the hypothesis? What is the hypothesis here? Assume the null hypothesis that assume the null hypothesis that the averages of two populations means BP and cholesterol are equal. That is a hypothesis which I am assuming. Okay, so simple. Remaining things, I look at the, see, I have executed this t-dot test, then write both data sets separated by commas. So this is the output actually. Look at the p-value. P-value is 6.892. E minus 16 means, how do we read this in our E minus 12 means, look at this, 6.892 E minus 12 means 6.892 into 10 power minus 12. 10 power minus 12. E minus 12 in R. 10 power minus 12. E raised to minus 12. R let E raised to E into 10 raised to. So this means 6.892 into 10 raised to minus 12, which is very much less than 0.05. 0.0000 something like that. So we reject the hypothesis that averages are equal. Reject the hypothesis that averages are equal. So what will be the final conclusion? Finally, hypothesis, we reject this. Equal enulladu reject cheyyuka. So there is difference, right? So final conclusion is there is difference between averages. Okay. Since p-value is less than 0.05, we reject the hypothesis that averages are equal. Whatever null hypothesis we set here, and always null hypothesis will be this thing for t-test. Don't change of your own choice. Don't change with your own choice. For all these tests, there is theoretically there is a setting of null hypothesis. Whatever be your attributes, in place of BP and cholesterol, whatever be your attributes, assume that they are equal, or assume that there is no difference. That would be the hypothesis which you can set. Okay, and also in the next step, actually, using in this t-test actually we call it as independent t-test. Independent t-test, if you want, you can make an assumption that variance of populations are equal. That is one optional. So we can assume that variance VAR dot equal. And here I took a different data set. That's all, just for just to show you. So if you assume that variances are equal, that also same code t dot s, then write those data names separated by commas. Then you please give this code also. This is only optional. Okay, I have pasted both codes in the chat. Over. So those who have finished, could you please import that grades file once again? Those who have finished, don't remove the CS2M dataset. Don't remove this. Please import that grades dataset once again. Grades dataset once again. So why I asked you to, anyway, import it. I'll show you. So once you finish that, please tell me. That is, finish that t-test, these two up to this.
Finished,
Then,
madam.
okay, thank you. Okay, grades, actually, why I asked you to import grades, the reason is that t-test, actually two types of t-test. This is one sample t-test. I have written here one sample. That is one set of variables. We have checked whether the average is some particular value or not. Then second one, actually, we have conducted independent t-test. You have two sets of data. We have to check whether the averages are equal or not. Now, next type of t-test is paired t-test. That means if you will be having a paired data, say, for example, here actually I am taking in the grade set data set, you have some quiz 1 and quiz 2. See, quiz 1, suppose I am choosing this quiz 1, quiz 2. Maybe quiz 1 I have conducted before starting this program, and quiz 2 might be conducted after this program. Okay, so some paired, some dependency is there. If you have some dependent data, we apply paired t-test, right? Paired t-test actually we apply for pair. That is why for the other test actually independent t-test തന്നെയാണ്. The other test is known as independent, but paired means actually paired, or that is dependent. Okay, so why I choose this data is that anyway in this CS2M all the data are independent. That is why I have gone back to grades. Okay, so how do we apply paired t-test, dependent test, t-test for grades by choosing columns quiz and quiz 1 and quiz 2. Code is same, t.test. Test. But inside a small difference, t.test test bracket, choose those data set quiz 1, then quiz 2, comma, paired equals t. That is the additional code which you are using for paired t-test. Paired equals t, capital T actually it is true. Meaning is that paired, P-A-I-R-E-D, paired. P is small letter, T is capital letter. Paired T. Okay. Conclusion, all those things same. P-value less than 0.05, we assume the hypothesis like that. So anyway. So here also we assume that there is no difference for these things. We have one data, quiz 1, quiz 2. There is no difference. Or I can say there is no difference means there is, suppose I am, okay, practically I will tell you this example. Quiz 1, suppose I conducted on the first day. Then I have given this training. Today, suppose I conduct, don't worry, I'm not going to conduct, just saying this example. Suppose I will conduct a test, a quiz after the, during the end of this program. So I want to check whether my training is effective or not. For that, we can use this test. Okay. So assume the hypothesis that there is no difference. No difference means not effective. Okay. So if this p-value is less than 0.05, we reject. Reject, no difference. That means there is difference. Of course, it is less than 0.05. There is difference means training is effective. Okay. So actually, I am not going in much detail of the theoretical part because we focus mainly on this workshop on R programming, programming part. Statistical part workshops we will concentrate more on that theoretical part. Just I am telling you, sharing you how do we interpret this. Okay. So t.test, paired t-test. So the t-test is over. And now the z-test. Z-test actually, what is the difference between t-test and z-test? Thing is that if you have this variables, number of values greater than 30, usually if it is greater than 30, we apply z-test. Less than 30, we apply t-test. That is only difference. Okay, so first two tests corresponding that average for checking average of a particular value, for checking the average, two sets of averages are equal or not. Same test we have in Z also. Z is actually normal test. But Z test is applied usually when number of samples is greater than 30. Here actually equal to 30, you can apply both Z test or T test. Anyway, I will show you that, but I don't know whether you will be able to do that because you require one package for Z test. Teaching demos. Check whether that package is there. If you have that package, you can do it. Otherwise, it will take time to install that package. That is why. For me, it is the teaching. Okay, you just listen. You can have a look at it because only difference is that the code is only difference is z.test. That's all. So please install this package and import it. Install, you can click here, right type here, then click this install. Okay. So after installing, don't forget to import that package. Usually participants or students will make that mistake, successfully install, but then they will forget to import. Install it first, then import it, then only do this code. Okay. So z.test, then I took the same data set CS2M, mu equals 40, average is 40, I'm going to check. And standard deviation equals, it is better to mention standard deviation in normal test, STDEV. It is better to mention standard deviation. Okay. So conclusion is same as the previous thing, 0.02212. What is the hypothesis which we set in this case? As same hypothesis here also you are using. Okay. So here this is actually greater than 0.05. So we accept the hypothesis. It is greater than 0.05. greater than 0.05. So we accept. Accept means average is 40. Okay, I think in a t-test also we have got like that. Teaching demos, do you have that teaching demos in your list of packages? Anybody checked? Anybody checked? Do you have that?
No, madam,
Okay.
it's not there.
Okay. No issue. Please install it later. Only small code is there. Okay. Please install it later. Okay. Now 2 more tests are there. Let me finish in 5 minutes. F test. Once you're familiar with doing 1 or 2 tests, it is very easy. Look at this. First one, T test. T dot test is the code. Then second one is a dot test. But in T dot test itself, if you are doing independent samples, then separated by commas. If you are doing paired T test, add a code, give this code also paired equals T. Then next is F test. F test is used for testing equality of variances. That is, you have, so I have showed you this one, averages of 2 populations are equal. Similar to that, if you want to test the hypothesis that variances of 2 populations are equal, then we proceed for F test. The code is, look at this. See, here actually, where is that? Yeah, here. Assume that null hypothesis that variances are equal. And the code is VAR dot test. Even though name is F, code is R code is VAR means variances. That means variances. Okay. The remaining same. Any 2 data set you can choose. Here actually I have chosen as, see, I am going to test whether, what is my aim? I am going to test whether, so see, this cholesterol, this age, these 2 columns comes from a huge population. I am going to check whether the variances of that population, columns corresponding to cholesterol and age, in that population are equal or not. Okay, the code is very simple. VAR dot test, then bracket whatever data which you are choosing, comma, separated by commas. Conclusion, all those things same conclusion. See, look at this p-value only for writing the conclusion. Can someone conclude this? P-value is less than 0.05. Right? 0.02 is less than 0.05. So we reject or accept?
Reject.
Reject. Yes. Thank you. Reject the hypothesis. So we reject the hypothesis that variances are equal. Reject the hypothesis that variances are equal means there is difference in variance. Right? There is difference in variances. Okay. So if you want, I can show you this chat. See. The next one is chi-square. Chi-square. Someone will pronounce it as chi-square. Usually, mathematics or statistics people pronounce it as chi-square. Chi-square, right? Anyway, whatever be the pronunciation, it is used for independence. If we have 2 attributes, suppose you are given 2 attributes. Okay, we have to check whether they are independent or not. I am going to check whether this anxiety level and drug. See here, sorry, here, this anxiety level, choose this column. Look at this. What is the difference between this column and the previous one? In the previous one, it is quantitative data. We applied t-test and z-test for and f-test for quantitative data. But this is qualitative. Qualitative in the sense you have only 0 or 1 categories. So you have to count. In chi-square, actually, automatically R will count number of items corresponding to 0, number of items corresponding to 1, like that. So I am going to check whether this anxiety level and drug are independent or not. For that, we can use chi-square. Code is very simple, CHISQ dot test. And what all data set you have, columns we want. That's it. Simple codes, only 1 line code. Not 1 line, 1 word code, I can say. Line is actually remaining since we are entering the data name, file name, etc. Okay, this is same, that interpretation is same as above. If this is less than 0.05, we reject, but here it is greater than 0.05. So we accept the hypothesis that they are independent. Okay, so those who want, you can do it. I square. Those who finish, please import one data set, sales city. Those who have finished this, please import one data set, sales city. So it is better to remove this one from this environment. Sales city, which is the last one. I will finish at sharp 4. Last test. Sales city also I have shared you. Yeah, this one. Okay. So A, B, C, D. City, different cities A, B, C, D and sales here. Okay. So here. Okay. So next is ANOVA, analysis of variance table. Here also actually just if you have multiple variables, more than 2 variables, equality we studied. 2 variables in case of t-test is a test like that. In case of t, let us take the case of t-test. Averages of 2 populations are equal or not. But in place of two populations, if you have more than 2 populations, right? If you have more than 2 populations, we will approach this test. But here I have given you a simple data set. See here, A, B, C, D, A, B, C, D. Okay, sales are given corresponding to A, B, C, D like that. So I want to check whether there is any difference between cities. So A, B, C, D, 4 cities are given. I want to check whether there is any significant difference between cities or averages of cities, right? So for that we use ANOVA. So first please import sales city, then AOV is the code. AOV, analysis of variance, that is the code. AOV in bracket sales prompt symbol, because we are going to check whether sales versus city. Sales versus city. That is why here actually I used prompt at approximation symbol, comma, data equals city. But if you attach that data set in between this code, it is enough to type only this. If you attach sales city, it is enough to AOV bracket sales prompt city. That's all. Okay. Okay. So for getting the results, please, because those who have done ANOVA manually, you know that some columns table we will prepare. So corresponding to that, if you want to get all those data, sum of squares due to residuals, all those things, please type this. But this is, look at this, this is the same thing. I have given a name, that is all. I have given the same code. This code is same as this code. Just I called it by a name. Okay, why I called it by a name? The thing is that I want to get that summary of those results. Okay, so let me run this. No new code. Okay, see. So if you once you get this summary, so those who have done this ANOVA, analysis of variance manually, they are familiar with this table. Degrees of freedom, sum of squares, mean sum of squares, F value. But finally, for conclusion in software, for conclusion, we require only this value. Check this P value. This is the P value, right? 6 point probability. This is the P value. 6.54 into 10 raised. E is into 10 raised to. 6.54 into 10 raised to minus 9, which is clearly less than 0.05. So we reject the hypothesis that there is no difference. We reject the hypothesis that there is no difference means final conclusion is there is difference between cities. There is difference between cities. Okay. So actually for getting this table only, I have given a name results. Results is the name which I have assigned. You are free to assign any name of your own choice in this place. So give some name that is equal to, equals means less than minus or simply equals. Less than minus or simply equals, then that same code, previous slide. Then to show the summary of results, summary bracket results, so that you will get this table. That is also optional. But usually while making projects or reports, we will do this also. So that's all my part. Testing of hypothesis, I have finished 4.2. Any queries, please? Any queries, please?
No, ma'am. No query.
Okay, thank you, thank you. Any others?
Thank you, ma'am.
Okay, thank you, thank you.
Thank you, ma'am. Thank
I
you so
think
much
you
for
all
your.
can follow with me. Only in between I skipped that box plot different options only. That's for if you want to give different colors or the all other things. I think you have done with me also. Okay. So if there is no other query, Rekha ma'am.
Yes,
Ma'am,
ma'am.
there was a parliamentary
Okay.
session.
Okay.
So I welcome Mrs. Darli AG, Director of Planning and Development. Ma'am, I welcome you for the welcome speech.
Thank you, Dunia. Good afternoon, all. A couple of days before, we all are eagerly waiting to know about statistical data analysis using R programming. Now, I can surely say that each one of us are certain about this particular topic. The most important thing which makes me more happy is the simple and informative presentation of our resource person, Dr. Bindu Krishnan.
Thank
In
you.
this valedictory session, my duty is to welcoming all. First of all, I would like to welcome of our respected principal, M.N. Mahin sir. Next, I welcome Mr. Jidesh.
2 days, and also I don't know what is exactly happened today, but yesterday I got some queries connected to registration for this event. So I think our efforts have made a fruitful to the for the very particularly our programming is not an interesting topic, but I think majority of the participants have very extremely participated in this program because the participation is more than 50. Our expectation is only just 30 numbers. We are talked to our resource person in that 3 or 4 days
Yes.
back. I think we expect only near to 50 only, ma'am. But now, so at the time of inauguration is 270, 72, 75. Then a regular participant is near to 50. So it's very well done happening this this program. So we are very happy. Also, we are eagerly waiting for the response of our participants of this program. I wish all the success for the participants who are participating in the last days and also today also. So and also we are very thankful to our resource person, Dr. Bindu Krishna ma'am. We very patiently and also discussed about the current topic, our programming. Thank you very much, ma'am, for associating with us. And also, we are expecting more programs like conducting connected to research and research-oriented activities. So I requested to the participants also your participation and also support for our near future programs. Thank you very much.
Thank you. Thank you.
Thank you, sir. Now I welcome our resource person, Dr. Bindu Krishnan Madam, for addressing us.
Oh, okay. Respected Principal Sir, IQAC Coordinator Jidesh Sir, Rekha Ma'am, and other dear faculty members, dear participants. I don't have actually much to share with you because last 3 days you are hearing continuously you are hearing me alone. So anyway, one thing, first of all, I would like to express my sincere thanks to the management, principal and core team of MES College for the opportunity given me here in handling these 3 days sessions. Actually, initially when we had a discussion with Rekha ma'am, we had ma'am suggested to conduct this 2 weeks, 2 hours. But I purposefully insisted that definitely if this testing of hypothesis is also included in this section, definitely we need at least 3 days, 6 hours. So then only you will be able to, because now audience will be from always, we expect audience from heterogeneous groups. Some may be aware of this basic R programming, but most of the people may not be aware of R programming, especially those attending a session like this, a basic level program. So also I don't want to simply show you, yeah, this is the code, this is how we execute. No. I want you also to get practice with me. Then only you will get, that will be beneficial to you. So I think, of course, I am satisfied with that. In between also many queries came, and so many participants was doing with me all the 3 days. And first of all, I thank to the participants for the patience in these 3 days. So anyway, I wish you all the best, dear participants. I wish you to do more advanced things in R, especially those who are doing research. Please focus on this program. Whatever be your area, either computer science or social science or science or whatever be the, irrespective of your area, this programming is very important. So do get practice with more. At present, you are in the track. I assure you that you are in the track. Now, whatever time you are planning to spend, definitely you will get benefit for that. You will be more involved in that. Okay. So once again, I wish you all the best, and once again, my sincere thanks to whole team behind this program. Thank you. Thank you all.
Thank you, ma'am. And now it's the time for the participants to share their experiences. I request participants to share your experience.
Hello,
Yes.
respected ma'am. It was a nice experience. Your class was so simple. You make it simple for us. Thank you very much, ma'am.
Thank you. Thank you.
Thank you, Adira. Any others?
Ma'am, I like your class very much. And initially, I don't like it very much. Now, your class is very interesting to me. It is very good class, ma'am.
Thank you. Thank you, Ashwini. But I request all the participants to get practice with it, because programming, that practice is very much needed. Definitely, I will share you the materials, both R codes, that R file, and PPT, which I shared you today itself. I'll post in Google Classroom. So those who missed in between, we can get practice with that. I think we can wind up.
Okay. So now I welcome Mrs. Rekha Rajendran, Director of Research Cell, for the vote of thanks.
Thank you, Dunia. Am I audible?
Yes, ma'am.
Okay. Respected Principal, Mr. Mahin M. Sir, Director Academics and Accuracy Coordinator, Mr. Jidesh K. Sir, Director Planning and Development, Mrs. Dali A.G. Ma'am, and our most valued resource person, Dr. Bindu Krishna Ma'am, all my dear colleagues and dear participants, good afternoon to all. First of all, I express my gratitude to our respected Principal Mahin Sir for his keen support and encouragement for conducting this workshop. Thank you, sir. Also, I express my sincere thanks to Mr. Jidesh, sir, for his valuable suggestions and support provided by him. Thank you, sir. I would also like to thank Mrs. Darling ma'am for her contribution to make the program a success. Thank you, ma'am. I, on behalf of MES College Erumely, Directorate of Research and Accuracy, and on my own behalf, extend a very hearty vote of thanks to our most valued resource person, Dr. Bindu Krishnan ma'am, for your effort and for sharing your valuable time with us. Your way of presentation and explanation was very simple and well understood. Thank you, ma'am. Thank you for sharing your knowledge.
Thank you.
I also express my thanks to Mr. Sabjan sir, Director IT Cell, for all his technical support, and also thank Kavita ma'am and Dunia ma'am for the support and cooperation. Last but not least, I thank all my colleagues, my PG students, and all the participants for making this workshop a successful. Thank you. Thank you all.
Thank you, ma'am. Finally, we can wind up our program with the national anthem.
Yes, sir. Yes, sir.
Okay. Thank you once again. Thank you. Thank you all. Thank you all. Thank you all.
Thank you, ma'am.
Thank you all.